Okay, so let's get it started. And so we have started discussing about the primitive type functional interfaces. So what I was telling in the other class, to understand the primitive type function interfaces, okay, the idea here is you need to understand the concept of auto boxing, the concept of auto unboxing, and also you need to understand the generic type parameter. So this understanding is necessary to understand the internal conversion. When you actually understand the internal conversion, like converting from one data type to converting from primitive to wrapper class conversions or wrapper class type to primitive conversions, so these things are already taken care by the compiler, but due to the frequent or due to the repeated conversion of auto boxing and auto unboxing, what is happening exactly is the performance is affected. Right, the performance is always selected. Why performance is affected? So when you're dealing with a particular data type, these interfaces are designed to accept the different data type. I mean, they are designed to accept the object types, not the primitive types. So the compiler will come into the picture, and when you are trying to pass the primitive types, that primitive types needs to get converted, auto boxing, right? And again, when you are working with the operators, the object types needs to get converted to primitive or unboxing. And there is some restriction in the type parameter. See, for all the interfaces, the type parameter should always be the object type. We will understand this with one more example. So this is just a repetition. I was just repeating it, which we have discussed in the previous session. Okay. So we have also discussed about the primitive type function interfaces. And what we need to ensure for the primitive type function interfaces. I think someone is joining in and someone is not able to catch them. I don't know who is it. Okay. So the process of what we call it as the primitive type function interfaces is called as what? If you have the data type as a fixed data type, if the input is always fixed, so there are some interfaces which is called as what? Int predicate, long predicate, and double predicate. These are the interfaces when you know that the input is always fixed. And we have discussed about this predicate primitive type function interfaces. And if you don't remember this, don't worry, we will understand this better with today's topic. Today's topic is primitive type function interfaces for function interface. Stay focused. Again, I'm not going to repeat this, but you will get a lot of idea just by focusing today's topic. So primitive type function interfaces. Let us help you with a small example. For example, let us say that I have a kind of function. You know what is a function? Function is an interface, right? Let us say that I have a kind of function. This is a function. Function is what? Function is an interface, and every time, so the function is going to deal with the input type, and in this example, the input type is integer. Let us say that the input type is integer. And again, there is an output type. Output type is also an integer. This is the input type, and this is the return type or the output type, right? And I am giving my own variable name as here. So my requirement is I want to find the square root of any given number. I want to find the square root of any given. I will pass a number like in the form of variable I. Let us say that my number is in the form of variable I, and I want to find its square root. So input is, this is defining the input, and the lambda expression operation is defining the output. I into I is nothing but the square root of the given input. Okay, you take the input and you find the square root for the given input, isn't it? Right? This is my simple lambda expression. We know this is a very simple lambda expression. Right? What I want to do, I want to invoke this lambda expression by using the apply method. Apply method is what? The one of the abstract methods in the function interface, right? So f dot apply. Okay. This apply method will expect a number. Let us say that you are passing a number 10. Focus here. Focus here. So you pass the number 10 here, right? And this time, this 10 is the input. Input is what? Integer, right? But the problem is you are passing the input as the primitive type. Focus. Okay. This is what type? This is what? Primitive type. So the input type is of primitive type. Okay. But my interface, function interface, is designed to accept the input as the object type or the wrapper class type. This is integer, int here. The simple difference is what? Okay, you are passing the input as the primitive type, which is small int, and the expected input is what? Integer, which is what? The object type. Okay, the input that you're passing, in this case you're passing 10. Okay, this 10 is what type? The primitive type. This 10 needs to get converted to the object type. What type it needs to get converted? Object type. This 10. Right? So what exactly happened? This conversion, okay, the input needs to get converted to from primitive type to object type, which is called as what? Auto boxing. This auto boxing will be taken care by what? Taken care by the compiler. Compiler is responsible to convert these things internally, right? So after this conversion, okay, so the input is converted. The 10 is converted to this 10. Then again, what happens? The mathematical operation, if you focus on this mathematical operation, you have an arithmetic operator. This arithmetic operator will always expect the primitive type in the both sides. Okay, firstly, what happened? The first thing is the input is converted to the input is primitive type, which is converted to the object type, which is called as auto boxing. So you collect the input here. Okay, input has been collected here, which is what? 10, right? So again, you are doing a mathematical operation as what? 10 into 10. Okay, the input is converted as the object type, isn't it? The input is converted as the object type, right? And again, to perform this mathematical operation, so the object type needs to get converted to the primitive type once again. That concept is called as what? Auto unboxing. Auto unboxing, right? After doing the auto unboxing, okay, the final output is going to be what? 100. Okay? And again, this 100 is of what? Primitive type. 100 is of what? Primitive type. Okay, so it is expecting the output as the object type once again. So again, this 100, okay, the as is 100 needs to get converted to what type? Object type. This integer. So what is happening behind the scenes? This is the input, guys, 10. Okay, you want this input to get convert. I mean, the compiler will convert this input to the 10, which is what? The object type. Okay, after collecting the input, you are performing what? You are using the lambda expression. Okay, this lambda expression is doing what? There is an operation called the mathematical operation. Okay, so this 10, both the 10 are what type? Object type and the object type, and you are performing a mathematical operation. But Java will not allow you to perform a mathematical operation for the object type. So these two objects needs to get converted to primitive types, auto unboxing. Okay, this 10 has to become 10 to perform the mathematical operation, primitive types. Okay, after the final result is going to be 100, which is also primitive type. Okay, and this final output again it needs to convert it to the object type. So here what is happening? Auto boxing is happening, auto unboxing is happening, and again auto boxing is happening. So 3 times for one input, these 3 conversions are happening for this particular code. This is a time consuming, and this is called as what? The performance is going to get down. Of course, you will get an answer for this. Of course, if you are using this lambda expression, you will get an answer. But internally, if I try to take a huge amount of input like this, let me take the input as integer, comma integer, right? Integer, comma integer, f equal to I want to find the square root of given number. For one number, there will be no issues. Okay, what if my requirement is I want to find the square root of the integer array? Let us say that my integer array is like 1, 2, 3, 4, 5, 6, 7. How many values are here? So there are many number of there are many numbers in the form of integer array. I want to find the square root of all these numbers. Okay, you go back and see for one input, auto boxing is happening, auto unboxing, and again auto unboxing. 3 operations are happening. For this many numbers, do you think that there will be many internal conversions which you are not able to visualize it properly? However, it will affect the performance. Don't you think so? Integer x in a. Okay, if you do this system.out.println, you will find the output. The output will be like what? The output will be good. I mean, you can see the output. Output is what? Output is as expected. You see the output. 1, 4, 9, 16, 25, 36, 49. You are seeing the output, but to generate this output, there is a lot of auto boxing, and the auto unboxing is happening behind the scenes. To avoid this, okay, Java 8 people has introduced a concept called, if you know that the input is fixed, okay, in this example, the input is of what type? Primitive type. All these inputs are primitive type. If you know that input is fixed, they are asking you to use the predefined primitive functional interface, which is called what? There is a function called IntFunction. The name itself says, when you are trying to use the IntFunction, the name itself says this int is representing the fixed input, which is what? Integer itself, primitive type integer itself. And if you're and output is, you need to specify the output as integer. Okay, because you want to find the square root of a given number. So you take an input can be in the form of j. We want to find the square root of the given input, which is what? J into j. And if you look at this code, if you look at this piece of lambda expression, okay, j into j. If you look at this piece of lambda expression, it is clear. Okay, this part is talking about the fixed input integer. Always it is going to take the integer as the primitive type, fixed integer, fixed primitive. Input is fixed. Input is fixed. Okay, what is this? Okay, fixed. Input is fixed. Okay, and the output you are specifying it here. When you take, instead of using this function, when you use this function, the advantage is, okay, the operation, okay, when you are applying this method, when you are using f.apply method, and when you are passing the input as 10, okay, this input, there is no conversion for this input, because the primitive type, okay, itself is a primitive type. No internal, it will not get converted to the object type, because input is fixed. Okay, 10 is always 10, and you perform the mathematical operation on this 10. Okay, and after this you are going to do what? You are going to get the output as which is what? Primitive type. Output is what? Primitive type, and only the output will be converted to what? This output is getting converted to the auto boxing, which is of what? The object type. As simple as that. Okay, only the output has to get converted. Only one conversion is required here. Auto boxing, primitive to object type. So in this previous example, you need to do auto boxing, auto unboxing, and again auto boxing. But here only one thing is happening. Only auto boxing is happening. So the performance is obviously better when you compare this function, this primitive function, with this ordinary function. Okay. Both are going to match the same output, but the performance wise there is a lot of difference internally, because since we are dealing with small inputs, no issues. But when you are dealing with a huge number of inputs, it is highly recommended to use what? IntFunction. What is that? IntFunction, fixed input, which is input type is always primitive, right? And the variable, output is integer, object type. F equal to I into I. Okay, then use the enhancer for loop. This enhancer for loop is going to accept the integer array in a system.out.println f.apply. What apply? Apply x. Every time first input 1 will be passed, and you will get the relevant output. 149. You may be asking me, sir, both are generating same output. What is the big difference? The big difference is the performance. Right, and if you look at this is giving you the difference. Only one thing is happening here, auto boxing only happening here, only one conversion is happening. But in this case, auto boxing has to happen, auto unboxing has to happen, again auto boxing has to happen. Compiler needs to take care of these 3 conversions. Here only one conversion is required. Right, for a specific level you can use this, but there are so many primitive interfaces that we are going to discuss now. Okay, this is the first example. I think you got some picture about this. Now let us understand the second example. My second example is, I have a string array, guys. See, this is going to be very interesting. I have an array of string. My string array is going to store some set of names. One is Ratna, second one is Shashwant, the third name is Jyoti, the fourth. Okay, let us stick to these names. And what I want to do, I want to accept each and every name. I want to find its length. Right? If I accept Ratna, the length of the name Ratna is what? 5. If I accept Shashwant, the length of the name Shashwant is what? 9, I think. If I accept Jyoti, the length of the name Jyoti is what? 6. Okay, for that I want to write a function. Okay, let me write a function. What is the input? Input is what? String. I need to accept a name in the form of string. What is the output? That is supposed to be integer, because when I accept input, it should return the length. Length is what? Integer, right? Integer. Return type. After doing this, let me give a meaningful name as f. F is equal to I dot length. Right? You take input and you find the length. Okay, this is the lambda expression that is going to give the length of the input. Length input is string, return type is length, right? And let me run this for loop for string x in the array names. If you run the enhanced for loop, and if you do the if you call the apply method on top of the reference variable, okay, and you will get the length. But there is a problem here. The Java 8 people saying, okay, there is a problem here, and they have also given a solution. What problem that you are seeing here? By looking at this code, what is the problem that we are going to see here? Let me minimize this. Okay. So you know, right? The first input is Ratna. No issues with the Ratna. Okay, Ratna will be the input because the input is of what type? String type. String, no issues, right? And after accepting the input, you are calling what? You are calling the length method on top of Ratna. Ratna dot length. No issues. It is going to find the length. Okay. It is after doing this, it is going to return the length as what? 5, right? Right. But if you focus here, this 5 is the primitive type. This 5 is what type? Primitive type. Primitive type. Okay. But the return type is what? The object type. It is like primitive type is what? This type, int. Okay. This small int needs to get converted to. Okay, this needs to get converted to this. What is the concept when you want to convert the primitive to object? Auto boxing. Right? Do you think that on auto boxing is being done by the compiler for one input, one auto boxing, for 3 inputs, 3 times auto boxing has to happen before returning the output? This output needs to go through the auto boxing so that the primitive type has to get converted to the object type, right? For the small data, no issues, but for the big data, it will have the huge impact on the performance. Don't you think so? To avoid this auto boxing, okay, to avoid this auto boxing, they have come with a predefined interface. Okay, when you are saying that you have the fixed return type, right? When you always want to deal with the return type, okay, they have come up with the interface called ToIntFunction. ToIntFunction. Okay, this ToIntFunction will accept the return type as the primitive type itself to avoid the auto boxing, right? So you do not want to define the return type here. Okay, only define the input type here. Okay, this is the the name of the interface, guys. Okay, the ToIntFunction. Okay, this part is representing the input. This part is representing the return type, and this part is representing the input type. Okay, when the value is returned, that value will be returned as the primitive type itself. No auto boxing is required. So this is ensuring that this auto boxing is avoided. Okay, let me write this for you for the better understanding. Same code, but I want to use what? ToIntFunction. Okay, the input type is string. Okay, this type parameter is talking about the input type, and the name ToInt is defining about the return type. That's why ToInt. Okay, f equal to We accept some input and find the length. That's it, right? And there is a twist here. What is the twist? Let me run the enhancer for loop to deal with each and every what we call it as every names in the string, the stringer. Okay, the array is of string type x in names, right? And after collecting each and every the string in the enhancer, in the array, what I want to apply? I want to apply the. Okay. So in this case, there is no apply method. You need to apply use the name of the method as applyAsInteger. Okay, when the return type is fixed, okay, you will be using the ToInt method so that it is going to avoid the auto boxing. And when you are using this particular function, a particular interface, you need to use the method as applyAsInteger. ApplyAsInteger means give me the return type as integer itself, primitive type itself. Okay, when you run this code, the output is going to be same, but what is the only difference that you have? Okay, let me take this back to the main screen. Let us compare this. Let's compare these two examples. These two examples are going to give you the same output, but the performance is better in this example. This example has high in performance. Okay, you accept the input as Ratna. Okay, Ratna is the input, right? First input. Okay, you are applying the length method on Ratna. Ratna dot length. Okay, after applying the length method on the string Ratna, this is going to give you the length, right? The length is going to be what? 5 itself, isn't it? 5 is the length. Okay, this 5 is the primitive type, right? This 5 is just like int. Okay, while returning this int, there will be no conversion here because this function will accept the primitive type only. ToInt means no need to do any conversion. So this will not go through the auto boxing internally. See, guys, the idea is you are avoiding the auto boxing and unboxing, nothing else. So you need to get used to it. You may be asking me why we need to learn this things. Okay, when you are dealing with the small data, no issues. But when you are dealing with the big data, if you have array of names, like in a college, there will be a lot of students. About 1,000 students will be there in some colleges. To deal with their names, okay, in the form of string array. If you are using the ordinary function, that is going to be a time consuming and the performance will be affected, right? In such cases, in the real-time examples, in the application development, you might be in a position, you might be in a decision making that you should be using this kind of interfaces for the better efficiency, better performance. Okay, let's see one more example for the better clarity. So my example is just a very simple example I will take. I want to find the square root of a given number. For example, let me say that I have array of numbers, guys. I have array of numbers. Okay, 4, 9, 16, 25, 36, 49. I have array of numbers. I want to find the square root of these numbers. What I want to do? I just want to find the square root of these numbers. Right? So the ordinary function will be like, you pass an input in the form of integer. Okay, and you are expecting the output in the form of double, because when I say double, it will have the floating values, isn't it? F equal to, accept the input in the form of 5, and you use the predefined function that math dot, there is a method called sqrt, right? And you pass I here, right? So what you are actually doing here, you pass integer, okay, and this math dot square root method is going to find the square root of the passed input. Okay, having said this, and you run the for loop, for enhanced for loop, right? And enhanced for loop is going to accept integer x in a. Some dot outer println f dot apply. Just use the apply method and pass the x. Okay, and when you run this code, for each and every number you got the square root. Okay. For 4 it's 2, for 9 it's 3. In the form of the value is in the form of double value. For 16, 4, For 25, 5, for 36, 6 and 7, right? And you might be asking what's wrong with this code. The code is fine, and why we need to reconsider, why we need to take the do the redecision, why need to look after this code. Okay, there is a problem in this code. What is the problem in this code? Okay, and you know that you are passing the first input is integer 4. This 4 is of what type? Primitive type, integer type. Good. 4 is of what type? Primitive type. But your function is accepting the wrapper class type, object type. So don't you think that the primitive input needs to get converted to the wrapper class input, which is called as what? Auto boxing. You do, a compiler will do the auto boxing, and it will convert the given input to what type? To object type. Yes or no? Right? So this input, okay, will get converted to what type? Object type. Auto boxing. One conversion. So this is going to get converted to object type. Okay, and let me take this input has to get converted to what type? Auto boxing object type. So after doing this, so you are applying math.square root method, and you are passing what? You are passing I. Okay, this I needs to get converted to the double type again. Okay, this I needs to get converted to what? Because you are passing the integer, and okay, you are applying the integer here. You will get the output as what? You will get the output as something like 4. I mean 2, right? For square root of 4 is what? 2.0, right? So this 2.0 is of what type? Small double type, primitive type. Okay. And again this primitive type needs to get converted to the object type, which is what? Capital double. I mean the double that starts with the capital D, object type. So this process is called as what again? Auto boxing. Two times the conversion is happening here. For how many times? For the 2 times. Okay. Why can't we take a interface which is going to avoid these conversions internally? Why compiler needs to get a burden to do these conversions for this kind of data conversions, for this kind of mathematical operations? Okay. So if you know that the input is fixed, and if you know that the output is also fixed, okay, in this case input is integer, output is double. There is a method called input is what? Integer, fixed. So int to double method is there. Very simple. When you use this method, and when you perform the same mathematical operation to find the square root of given set of numbers, okay, to find the square root of given set of numbers, you can avoid the internal auto boxing or auto boxing 2 conversions. Compiler, you are reducing the burden to the compiler. Very simple interface, int to double. Okay, this is talking about the input type, this is talking about the return type. Very simple. I can apply the same method here. Instead of this function, I can use IntToDoubleFunction. Right? No need to specify the type parameter, because this itself is saying that this itself is this function IntToDoubleFunction itself is saying that sorry, this is IntToDoubleFunction. Okay, I missed the function here. IntToDoubleFunction. This itself is saying that input is integer, output is double. Okay, when you run this code and there is a twist here, you can't use apply. You should use apply as double. When you are fixing the return type as the double type, the abstract method will be changed. Okay, when you are not fixing the return type as double type, no issues. But when you are fixing the return type as some other type, you need to ensure that you are using this as that some other type. If it is double, it should be double. If it is long, it should be long as the type. Okay, when you run this code, you will get the same output. 2, 3, 4, 5, 6, 7. There is no difference in the output. What is the difference? Only the performance wise, this is better. Right? So this is the main idea about the predefined primitive type function interfaces. Okay, there are many predefined primitive type function interfaces. Let me introduce each and every type. You have IntFunction. First one is IntFunction. Okay, by looking at this, you need to identify IntFunction. Okay, this R is talking about the return type. Okay, this is accepting as the input, and this R is talking about the return type, and the input is public or apply, and the name of the method is apply method. This apply method is going to accept the integer as the primitive type itself. So this is talking about the input type, and this is talking about the return type. So this is the first method. So when you know that the return type, the input type is always fixed. Okay, in this case, the input type is always fixed, like integer type, integer primitive type. Then you can use this interface. When you know that the input type is fixed, like long type. Okay, let me use this long type. Long function. Okay, what does it really mean, guys? Long function. Second interface. Long function, and the return type is R itself. Okay, you are saying that the input is always long type. Input is fixed as long type, primitive type. Output is R apply. Input is long. Right? Like that, you have the third function. Okay, which is what? By looking at this naming conventions, you can identify what this function interface is going to do. You have the double function. Okay. This double function, by looking at this, you should be able to guess what this function and primitive function type is going to do. Input type is double, and the return type can be anything. Okay, so you are fixing, when you know that the input types are fixed. Okay, you can use this. No matter what the return type is, when you know that the input type is the fixed data type, primitive data type, you can use this method. This is going to accept the primitive integer as input, long integer as input, and long as input, double primitive type as input. Return type can be anything. It's up to you. Depends upon the requirement. And we have the fourth interface, which is called as ToIntFunction. Just work on this examples. ToIntFunction. ToInt is this is when you know that the return type is fixed this time. Previously, when you know that the input type is fixed, you can use this. When you know that the return type is fixed, just add the prefix. I mean, just use the to prefix in the beginning of the predicate. I mean, in the beginning of the function. I mean, interface name. Right. So here, this to is defining about the return type. Right. What is it is going to return? Integer type, public integer, applyAsInt, apply as int method. Okay, the input type can be anything. Like this, you have you have ToIntFunction, you have ToLongFunction, and you have ToDoubleFunction. Okay, two integer, two long, two double. Right, so these are the interfaces that you have for the function interface. Okay. When you work with first three examples, these things are going to be very easy. Just you are going to understand the conversions. Okay, like this, we have the another set of interfaces which are like IntToLong. There is a function called IntToLong. This is talking about the input type. This is talking about the return type. Both are primitive types itself. Right. So IntToLongFunction. This has the method called public. Okay. Long is the return type. So small long. Apply as. What is the input type? Input type is integer. So applyAsLong. Input type is integer. In the parameter, you pass the integer. This is the name of the abstract method. Like this, you have three other methods like IntToLong, you have IntToDouble, you have. Okay, and this is going to be what? This is going to be double. And you have IntToLongFunction int to long, int to double, and you have long to int, long to double. Okay. This is input type and this is the return type. Input type, this is the return type. Okay. Next, there are three more interfaces. Long to int function is there. Long to int function. The first one is talking about the input type. Second one is talking about the return type. Apply as double. Long. Parameters always consume the input and the return types, or the second one is return type, first one is the input type. Right? And there are like this, there are two other methods. Long to int, long to double function is there. Double function, okay, and this is what return type is. Okay. And we have double to int and double to long function. Don't think that this is boring. When you work this out, okay, this will be mind blowing. Double to int function, okay, and 11. Double to int function, which return apply as integer. So this is going to accept the double as the input type. 11th one, and you have the 12th one, double to long function. This is what long, apply as long. Right? Don't feel uncomfortable with the names. Okay, this is not a kind of complicated things. Once you work with the first three examples, these examples are going to be very easy. You assume the input and the output. When you know that the input and outputs are fixed, you can use these interfaces. When you already know that the inputs or outputs are fixed, so you are just avoiding the auto boxing and unboxing, guys. Okay, just repeat these concepts which I have discussed before, this auto boxing and unboxing. When you understand this auto boxing and unboxing, you will understand why you need to work with these interfaces, especially to increase the performance. Okay, there is another three more interfaces are there. We will conclude this. The three more interfaces are, there is an interface called ToInt by function, I think. ToInt by function. Okay, let us understand the beauty of this interface. This is the return type. ToInt is return type, and the input type is what? By function. It is going to accept two inputs. Okay. The name of the method is public int apply as int. This is going to accept two inputs. You know what is a by function? By function will accept two inputs. One is t type, second one is u type, which we have already discussed. Okay. Like this, we have the last two interfaces. Okay. ToLong by function is there. Okay. This ToLong by function will accept the return type is long, and the name of the method is what? Long. ApplyAsLong. Okay, and the last one is ToDouble by function. ToDouble by function. T and U, and since it is going to be a double type, return type is double type. ToDouble means return type double. So this is going to be what? Apply as double. Okay, so I don't think you need much explanation on this. Try to solve the first three examples that we have just discussed. Okay, first three examples. Try to do this observation, what is happening behind the scenes. Okay, auto boxing is happening behind the scenes, auto unboxing is happening behind the scenes. And again, while returning it, okay, to avoid these two conversions, you use this primitive type function interfaces. As simple as that. A lot of auto boxing and auto unboxing is happening. We are just trying to avoid that to increase the performance. Okay, that's all about the function interface, primitive type function interfaces. Okay, and tomorrow we'll start discussing about the consumer primitive type consumer interfaces. I mean, primitive type function interfaces for consumer supplier. When you understand all these things, you will understand the importance of the stream APIs. Okay, that is really hard to understand, but to understand that, to make that topic very simple, I am explaining all these things. You will not have any confusion once you repeat this. If you're finding any difficulties, you can approach me anytime. I will be happy to help.